We're going to do two more problems involving finding the sum of an infinite geometric series. The first of which is a multiple choice problem. We're asked to, what is the sum of the infinite geometric series 1 minus 3 plus 9 minus 27 plus ... So, first thing with any geometric series, if we're asked to find the sum, is we need to find the common ratio. What am I multiplying by as I go from term to term? Well, to go from 1 to negative 3, and from negative 3 to 9, and 9 to negative 27, looks to me like R, my common ratio, is negative 3. So, can I find the sum of the infinite geometric series? Well, here was our formula to do so. However, this formula only worked. I could only find the sum of an infinite geometric series if my common ratio had an absolute value that was less than 1. Well, the absolute value of negative 3 is positive 3, which is not less than 1. This thing is going to keep growing. I'm going to keep having bigger and bigger numbers, which means the sum is going to diverge, it's going to expand. I'm not going to be able to find the sum of this infinite series. So, that being the case, because R, my ratio, is not fitting of what I need it to be to use the formula, I'd say that this sum does not exist. Okay? In the next problem, we're told that we have a pendulum that is released to swing freely, and it travels 18 inches on the first swing. So here goes, travels 18 inches. And then on the way, each successive swing, pendulum travels 80% of the distance of the previous swing. What's the total distance the pendulum swings? So it goes, 18 inches this way, and then back, and then back, and back, and back. And eventually it's going to stop and slow down and be basically nothing. It's going to stop swinging, okay? This is an example of an infinite geometric series, of which we can find a sum. Because what's happening is the distance that it travels is 80% of what it was previously. 80% in a multiplication problem is going to be written like this, 0.8. Maybe it's too small to see. The distance it's going to travel on the second swing is going to be 18 times 0.8. And then times 0.8 again, so that's 0.8 squared. Okay? 0.8, 0.8, 80%, that's my common ratio. That's less than 1. This is an infinite geometric series that's going to have a sum. If I were to write this using sigma notation and to figure out the sum, well, here's what it would look like. My rule is going to be 18 times 0.8 raised to the n minus 1 power. And I'm going to find the sum from n equals 1 to infinity. Now here's the problem. You can't type that into your calculator because you can't take it to infinity. So we're going to need to use our formula. The sum is equal to the first term divided by 1 minus the common ratio. Again, do I know these things and can I plug them in? Well, the first term was 18 because that's how far I traveled on the first swing. My common ratio is 0.8 because I'm going 80% of the distance. So 1 minus 0.8 goes here. The decimals may even be a little bit easier. So as I simplify this expression, 18 is going to be divided by 0.2. And when all is said and done, 18 divided by 0.2 is going to be 90. So 90, that's the total distance that it traveled, and it was in inches, so I'll go ahead and label it as such. 90 inches would be the total distance traveled by the pendulum as it swung back and forth until it was done.